the problem is called Palindrome Partitioning. Okay, Palindrome Partitioning. So given a string S, we need to partition S such that every substring of the partition is a palindrome and return all the possible palindromes. A palindrome is a string that can be read the same backward and forward. Okay, so let's look at this string. Okay, this string. So it's saying that a good output would be A. So the string is AAB. So A, and B. Each of them is a good palindrome. Each of them can be read the same. And A can be read the same backward and forward. All is good. Another option to split it is AA and then B. And AA can be read the same backward and forward, and B can be read the same backward and forward. Okay. There is another example. If the only input is A, then A can be read backward and forward. So a not good result would be for B to split it here, because A can be read the same way backward and forward, and AB cannot. So in this case it cannot be. So let's just try to solve it manually and see which tips we get. So let's say that we have here this A, B. How would you solve it manually? This is a good question. Solve it manually. I would say I would need to check all the... Basically, I need to check all the substrings, right? Because each substring can be a palindrome. So, but I will start from here. Let's start by checking A. A is a palindrome? Yes. Good. Add it to some kind of a temporal list, because we are currently doing good. Okay, so now I'm left with A and B. Okay, so I could again check this A this way. A is a palindrome? Yes. Add it to the current list. Check the rest. B is a palindrome? Yes. Good. Check it. Add it to the current list. And now go to the next item in the list. The next item is empty. Empty is a palindrome? Yes. But it's empty. No need to add it. Just take this current. It was a good result. Add it to some kind of a global result object and return it. Next, in the next step. Okay, let's start over. Okay, now we finished. It's like we finished with the first character. You see, we finished with splitting by the first character. And now we want to try what happens with this combination. Okay, so we start now with this combination. A is a palindrome? Yes, good. Add it to current. And now what's left? B. B is a palindrome? Good. Add it to the current. Now what's left? Empty. Empty is like a base case. Nothing to add here. Good. We finished. We reached the base case. Add current to the result and return. Okay. Now what happened in case that we didn't work out for us? Let's see. Okay. If we had this again, A, B. You see here, we have here like a for loop, where in each step we first take, if I is 1, we take the first character, I is 2, we take the first 2 characters, I is 3, we take the first 3. But let's start with I is 1, okay? I is 1, we start with A. And next, we want to ask some function, do we have find a result of a palindrome in this place? So it could find again first by the first method that we did, A and then B, which were always perfectly good. But because we say it's a recursion and we see here we have the for loop, then it could also try this AB. What do we want to do in this case that it's trying this? So this current, we added the A to the current. Now we don't we don't want this to be in the current, right? So we want to have a step back and to start all over. and then a step back. Okay, so let's to continue in our recursion. And in case we'll see that we added this by any chance to the current, we need to remove this. Okay, we need to remove this from the current, and we also need to step back and remove it. Okay, let's now try to actually code this. So we see that we have a lot of combinations in the result, which hints it's recursive, because we asked about the first part and then about the second part. In addition, another tip that we see is that we are splitting the array, like to head and tail, and we ask the helper recursive method to solve the tail. Okay, and we have a base case. Everything is just falling down to recursion. We have here also a base case. Okay, so basically whenever we have a problem with recursion, it's always good to call some helper method here with the string s. Usually we're going to have additional parameters. Let's see how it's going. Okay, so let's try to write this recursive problem function. So it's going to be a list of string. This is the same result as the main function, and here we call this helper. We receive string s, and now what do we want to do? We want to check the base case. First we checked always in recursion, check base case. Okay, what is the base case? If s.length is empty, no, if a string is empty or s.length is empty, same, then we want to return the result. We don't have anything yet in the result, but we said that we need a current variable. Let's see where the current variable will get it from. We need to return the result, and we also said that in the best case we need to add the current. So we need to add, because you remember here when we started with this, when we started with A, B, and then we said we have A and then A, and every time we add it to the current variable and then B. Then when we reach the edge case, we said we now take the current, add it to the result. So let's do this. Let's take the current, add it to the result, dot add current, and return the result. Okay, so we already see that we need here two new variables to pass. This is going to be a list of string, which is the current. This is going to be a list of string, which is the result. Okay. And now let's start this traversal, because we said we are going to have here a traversal with a for loop. So let's start this traversal. For int I is starting from the first character. You see immediately I is less than s.length, I plus plus, and then what is the head? The head is the substring, s.substring, and the first argument substring is inclusive, so it's going to be start from the first characters that we have and exclusive I. So if in the input here we had A, this would say take from 0 to 1 exclusive. Not this one, only character number 0. Okay, looks good. What is the tail? String tail, s.substring, the rest. So basically we want inclusive I and s.length. The problem here, as we see, is that if we had here A, B, it would be good, because if we took A, now we'll take B. But if we had only A, then this would start from I inclusive from here, until the length, and this I think could result in the index out of bound because there is nothing here. Let's see if it fails here. If it fails, we'll add some check. And now we said that, okay, we have the head, we have the tail. Let's check. It's always in recursion. Let's check if the head is applying some what we want, which is if is palindrome of head. If it is a palindrome, we want to add it to the current results, right? Want to add it to the current result, and we want to call the helper tail cur and result. And after we call the helper, and the helper is returning. So if everything was okay, we added the result and we returned it. However, we know that we are not in this case. If we were in this case, then we would return here. So if we reached this loop, this means we have more than one item. And since we return here, we need to pop the latest item because we're here in a problematic result. We need to pop out the current item, latest one. This is the latest item that we return. Now we return the result. This is very delicate, actually. The reason of why we remove this item, because you say, okay, you just call the helper method. Why do you assume you are now in a bad use case? So the reason is this. If we are here, this means that we are scanning the string. What is the condition that we are scanning the string, and we need basically to traverse the tree. So we have another item we already called helper. If we were at the base case, which is the good case, where we add result to the result, then everything was good. Here we finished, but here it's not that it's a bad case or that it's not a good result. This only means that either our recursion finished with a good case, so we are at the bottom, so we need to pop up after each such returning. We are popping up all the items until we get to the root, and when we get to the root, we continue to the next use case if this was a good case, and also in case this was a bad case. If this was a bad case, we simply didn't reach this item, and we just remove the latest item to continue in the recursion. So now what's left for us is to implement the palindrome, which is quite a simple function to implement. This I think actually should be here. Okay, turn this. Okay, so to implement the palindrome, it's returning a boolean is_pal, and it's accepting a string s. And basically what we're going to do is that if the string s.length is equal or to 1, then it's a palindrome. Okay, no need to waste lines here. Simply palindrome, return true. Else, we need to check if it's a palindrome. So we want to do this recursively, no need. For int I is 0 until I is at the end. Plus, if one of them is not equal to the other side, then return false. Okay, if char at I is not equal to s dot char at s dot length -1 minus I, then return false, and all is good. Okay, let's try to run it and see what's going on. Okay, so here we need to initialize the new variable. So this would be the current. It's just a new array list of type string, and the result is new array list of type list of type string. Okay, running this. res.add.cur, no curly braces, and here you see, because we add the cur, we don't want to continue to use actually the same current. Let's see also here what we have. Okay, if s.chart, what's the problem? Cannot find symbol. Length. Okay, length should be with lowercase. Okay, so see, we returned everything empty, and the reason is, you see, we pop everything and we continue popping, but we need actually to have the cur to be a new one. When we finished with the use case, we want the current to, let's initialize it, reference a different array list, and all would be good. And also when we add the result, we want a new array list, not a new reference. We don't want to mess, because you see we pass here the variables, we don't want them to be the same. Let's try again. Let's see if we have here this index out of bound, which I suspected we could have. No, looks good. Okay, so let's submit it. If it's okay, we'll go through the code once again. Okay, looks good. Let's go through this code once again. Okay, so we said that we are going to go to the string one by one. If the base case is that we have no items, then we add the current result to the result, and otherwise we could just scan the string. So we start with the first character, which is the first character, and this is going to be head, and the tail is going to be the rest of the string. Okay. Next thing is that we are going to check if the head is a palindrome. If it is, all is good. Then let's actually draw this. Okay, so next thing, we check if the item is a palindrome. Okay, if it's a palindrome, okay, so we had this A, B. We check if this head is a palindrome. Yes, check. Add it to the current. Okay, here we add it to the current. And here we call the helper for the rest of the string. After we call the helper would start again from the beginning of the function. Okay, and it would reach here again, and then reach here again. And when we finish calling the helper, okay, we want to pop it out, either because it was not, or because it's a false answer. And then we move on to the is a palindrome, which is a function that just go and scans the strings and check if it's okay or not. So this was it. This was how to check for palindromes. Inside a string, I have this was helpful. I think this was interesting, and see you next time.